Okay, if you remember at the end of last half term, we looked at sequences. We started off by looking at linear sequences, we looked at geometric sequences, and then we moved on to Fibonacci. Right on the very last lesson, which was on the Friday of that last half term, we did just start looking at quadratic nth term. So what I want to do in the first lesson when we return is to dive a little bit more into what the quadratic nth term is and how we go about actually doing a question. Now you will notice, because I've just noticed after recording most of this, there is a spelling error on most of the slides. So I will know if you've watched this, because then you'll know what the spelling error is. So please do have a look at this. This is designed for both 11x1 and 11x2. Now I know Miss Grab's class has looked at some of this already, so if this is something that you are really confident with, you don't need to talk through or you don't need to watch the video, go straight on to the questions. Next lesson we will be looking at making this slightly more complicated, looking at some problem solving questions and looking at some questions where you might end up with some form of diagram where you need to create the quadratic nth term. If you have any problems, then feel free to just send me an email or to email Miss Grab, and hopefully you were all okay and had a brilliant Christmas. Okay, so first thing we're going to do is have a look at the sequence we've got. So we've got -1, 5, 15, 29 and 47, and we've asked what is the nth term of this sequence. So we did look at this right at the end of very last half term. I want to give you a couple of minutes to see if you can tell me which is the nth term and what actually we went on to look at when we were looking at this sequence. It was the very last Friday of half term. Okay, so let's have a look then. So the sequence, it goes -1, 5. So if we have a look at what is happening from here to here, we know we are adding 6. Have a look what's happening to go from 5 to 15, we are adding 10. If we continue 15 to 29, we are adding 14. So this sequence here is not a linear sequence. The reason it's not a linear sequence is it's because we're not going up by the same quantity each time. So we know it can't be 6n minus 7 because this difference here is not 6. We know it can't be -1n plus 6. We know it can't be 6 minus 1n. It is not a linear sequence, so it is none of these. We did one example right at the very end. I'm going to look at two alternative methods that you can use. Now I know Miss Grab's group have used the traditional method, and the first example I did with my group was a slightly different method which is linking to what the quadratic formula is. So that's where we're going to start. So the first question we'll get is, what is a quadratic? Now if you think about it, we've worked with quadratics a number of times. So typical quadratic, I would have 2x squared plus 9x plus 10. So a quadratic means that the highest power or the highest term we have is a squared term. If you remember when we were working with quadratics earlier on, well, last year, we looked at using the quadratic formula. When we used the quadratic formula, we said that the coefficient in front of the x squared was our a, so this was our coefficient a. The x term was b, and the end term was c. The general equation for a quadratic is the following. So it's ax squared plus bx plus c. Now we're interested in the nth term. So with respect to an nth term, I'm talking an squared plus bn plus c. A b and c are integers, they are coefficients, and they can be positive or they can be negative. So when we're looking for the nth term of a quadratic sequence, we're looking for something in this form. So an example might be n squared plus 4, which would mean the a would equal 1, b would be 0, and the c would be 4. Could have something along the lines of 2n squared plus n minus 1, something along these lines. So this is what the general or the nth term of a quadratic sequence would look like. So now what we're going to do is we're going to take a sequence and we're going to derive its nth term. Okay, so the first example we're looking for, and the first one we're going to find the nth term for, is 0, 6, 16, 30 and 48. So the first thing I do every time is I look at what the difference is going from one term to the next. So that's the first thing I'm going to calculate. So add in 6, add in 10, add in 14 and adding 18 each time. And we call this the first difference. If you notice, these are not consistent. It is not the same value each time, and in that case that means we need to calculate a second difference. So looking at the second difference, this time we have add 4 again and add 4 again. So the second difference is the same. Now the second difference is add 4, and there's a bit of a rule that we need to learn. So when we're talking about second differences, if the second difference is 2, it means the sequence is linked to n squared. If the second difference is 4, it's linked to 2n squared. If the second difference is 6, it's linked to 3n squared. So I know that my second difference here is 4, so it means that the start of my quadratic nth term would be 2n squared. Now we need to figure out what is going to continue after that. So I'm just going to write out what the sequence 2n squared would be. So if I think about n squared itself, it's pretty straightforward. So my first term in n squared would be 1, because 1 times 1 is 1. Second one would be 4, 2 squared. Next one would be 9, 3 squared. Next one would be 16. This would be 4 squared. What about 2n squared then? What would that look like? Well, 2n squared, I'm just going to double each of the terms that we have above. So we know if it was to start as 2n squared, the sequence would start as 2, 8, 8. So my next step after writing down 2n squared is to subtract 2n squared from the sequence that we started with. So the first thing I will do is just going to write down out my sequence. My sequence is 0, 6, 16 and 30. This is our sequence. I'm going to subtract 2n squared, which is 2, 8, 18 and 32. So we're going to subtract the two sequences from each other. Now you should notice in each case that gives me minus 2. This means that our sequence has the same difference when I subtract each one. So the sequence overall become 2n squared minus 2. Now this isn't always the case. We don't always get here the same number. We don't always get this when we take the 2 away from each other, and it does become more complicated. But for the first example that we're looking at, I would get as my final nth term 2n squared minus 2. Okay, so we know when we're looking for the nth term of a quadratic sequence, first of all we work out the first difference. The first difference is not this constant, then we will look at the second difference. When the second difference is constant, we know we are looking at a quadratic sequence. We know the general form of a quadratic is an squared plus bn plus c, and we need to work out for the sequence we're given the value of a, value of b and the value of c. Now I just want you to ignore this table for the time being. For anybody who is interested, I can talk you through why the following rule applies. For those who just want to initially establish how to get this to work, then we need to take down 3 key pieces of information. I need to know that the second difference is equal to 2a. I need to know if I take the first term of my sequence and the second term of my sequence and subtract the first term, that would equal 3a add b. And I need to know that the first term is the same as adding a, b and c together. So the first thing we're going to do is just write those 3 pieces of information down, and then we're going to have a go at using the same sequence as in the previous example to derive the same answer. Okay, so before I start this example, I'm just going to write down my key facts that I have currently learnt. So I know that 2a is equal to the second difference. I know that 3a add b is equal to my second term minus my first term. And I know that a add b add c is equal to the first term. As I said previously, anybody who would like to understand the proof behind this, then please let me know and I will create you a separate video on that. So the first thing I'm going to do, I've already done this on the previous example, is first difference, which we knew was 6, add 10, add 14, add 18. Second difference, this is the important one. So the second difference is add 4. So the first thing I'm going to do is use this formula here. So I know that 2a is equal to the second difference. So 2a is equal to 4, because the second difference is 4, which means a is equal to 2. First part done, reasonably straightforward. Next thing I'm going to have a look at is 3a add b is equal to the second term, take away the first term. So I've got 3a add b is equal to the second term. The second term is 6. Take away the first term, which is 0. So I know that 3a add b is equal to 6. However, I also know that a is equal to 2. So I know that 3 times 2 add b is equal to 6. I've got 6 add b is equal to 6. So in this case, I know b has got to be equal to 0. So far I've got the value of a, and I've now worked out the value of b. Final step is a add b add c is equal to the first term. So a add b add c is equal to the first term, and our first term is 0. A is equal to 2, so I've got 2 add 0 from a b add c is equal to 0. So rearrange, I know that c is equal to minus 2. So my nth term we know takes the form of an squared plus bn plus c. A is equal to 2, so it's 2n squared. B is equal to 0, so that term disappears. C is equal to minus 2. So it's exactly the same answer as the previous example, but it's just a different method. Now the method I'm going to use throughout the rest of these examples is following this method. If you have been taught, and I know Miss Grabs has, by using the traditional method, then please follow through, have a go at the examples and check that you are getting the correct answers. For my class, please have a go at using this method, because this will be the method that I continue to use when we come back into school. Okay, so let's have a look at another example. So again, I'm going to use the same method. I know that 2a is equal to my second difference. I know that 3a add b is equal to the second term minus the first term. And I also know that a add b add c is equal to my first term. So if I have a look at what the difference is, first one, add 9, then I'm adding 15, then I'm adding 21, then we're adding 27. So if we have a look at the first difference, you can see it's not a linear sequence. If we carry on, we know we are adding 6 in all cases. So we know it's definitely a quadratic nth term, and we know that 2a is equal to a second difference, which is 6. So in this case, we know a has got to be equal to 3. Next thing we're going to have a look at is we know that 3a add b is equal to a second term, which is 14. Take away the first term, which is 5. So we know that 3a add b is equal to 9. We know that a is equal to 3, so we've got 3 times 3, add b is equal to 9. Similar to what we had last time, we've got 9, add b is equal to 9. So again, in this case, we know that b has got to be equal to 0. Finally, I know that a add b add c is equal to the first term, and the first term is 5. A is equal to 3, b is equal to 0, add c, so therefore we know that c would be equal to 2. So the nth term for this sequence would be 3n squared, there is no b term, add 2. Now I could just double check to make sure I've done this right. So I know whenever I'm looking at the first term, n would always be 1. So 1 squared would be 1. 1 times 3 is 3. Add 2 would give me 5. Let's check it's definitely right. Second term, n would be 2. 2 squared is 4. 4 times 3 is 12. 12 add 2 is 14. We're definitely correct. So we know that our nth term for this particular sequence is 3n squared add 2. Okay, for this third example, I want you to pause the video please and have a go at completing this on your own. Have a go, pause it, and then in a moment I will write you up a solution to double check you are on the right track. So hopefully you've had a go at doing this. As always, the first thing we're writing down, first difference, second difference. So adding 8, adding 12, adding 16, adding 20. If we have a look at what the second difference is, the second difference is add 4. Now hopefully you will start to memorise what these formulas are. So the first thing I know is that 2a is the second difference is 4, so I know that a is equal to 2. Next thing I'm going to do is I know 3a add b is equal to my second term, take away my first term, so I know that 3a add b is equal to 8. I know the value of a is equal to 2, so I've got 3 times 2 add b is equal to 8, so I have 6 add b equals 8, so I know that in this case b also is equal to a value of 2. Final thing is a add b add c is equal to my first term. My first term for my sequence was 4, so I have a is equal to 2, b is also equal to 2, c is equal to 4, so we've got a, 2 add c equals 4, so we can see in this case c has got to be equal to 0. So your final nth term, so it's going to be 2n squared, the b is equal to 2 plus 2n, but we have no equivalent coefficient on the end. Okay, so same applies for example number 4 as we did with the previous example. I want you to pause the video, I want you to have a go at working out the nth term, and then when you're ready to have a go at checking your solution and double checking it is the same as what I have got. So have a go at pausing the video at the moment then please. Okay, so just checking your answers, making sure you're on the right track. If we have a look here, I'm adding 3, I'm adding 7, I'm adding 11, and I'm adding 15. Check what my second difference is, and my second difference is add 4. Again, hopefully we're getting pretty good at recalling these formulas. So 2a is equal to the second difference, which tells me a is equal to 2. Then I know that 3a add b is equal to second term, subtract the first term, so 6, take away 3. So I know 3a add b is equal to 3. I know 3a, well, a is equal to 2, so I've got 3 times 2. So 3 times 2 add b is equal to 3. 6 add b is equal to 3. So b is equal to negative 3 in this case, because we 3 take away 6. We know that a add b add c is equal to our first term, which is 3. So if we substitute in what we've got so far, we've got 2 add minus 3 add c is equal to 3. So we've got negative 1 add c is equal to 3. So now the value of c has got to be equal to 4. So in this case, my nth term would give me 2n squared minus 3n add 4. And hopefully you got that same answer. Okay, if you're feeling really confident, then you don't need to have a go at this example. You can go straight onto the work that's being set on the website. If you just want to do one more to double check you're on the right track, then again, have a go at freezing this, and then in a moment I will talk you through the solution. Okay, so every time I'm looking at what the difference is between the terms, so I've got add 8, I have got add 12, I have got add 16 and add 20. So we will then go to a second difference. You can see the second difference is add 4. That tells me that 2a is equal to 4, which means a is equal to 2. I know that 3a add b is equal to the second term, take the first term. So 8, take off 0. So 3a add b is equal to 8. I know that a is equal to 2, so I can substitute it in here. So 3 times 2 add b is equal to 8. So I've got 6 add b is equal to 8. So the value of b also has to be 2. Final thing is a add b add c is equal to our first term, which in this case is 0. So I've got 2 add 2 add c is equal to 0. So I know that c would have to equal negative 4. Final step, put it all together. So my nth term would be 2n squared plus 2n take away 4. So again, double check you've got it correct. If you're happy with this, then please move on to the website and have a look at having a go at some of these questions.